Today we're going to talk about completed square form. We all know that while solving some quadratic equations, sometimes a question just asks us to write this equation in a completed square form. Or we might need to use it in some cases where we need this form desperately. So let's talk more about what this form is. We all know all the quadratic equations look something like this, like ax squared plus bx plus c, where this x squared terms tells you it's a quadratic equation. Now, a completed square form looks a bit different. It doesn't look like this. It looks like a x minus h squared plus k. Now, in this, a is still the same coefficient as the above thing, so it means it holds the same thing. Like if a is negative, then we all know we're gonna get a sad face, but if a is positive, we're gonna get a happy face of a parabola. So this thing still remains for both the equations. Now this h comma k, this h and k is a coordinate. This is the turning point, or it is called the vertex. Now, just a reminder to those who don't know what vertex is. Vertex is the minimum or the maximum of a point, or in short, a point where the graph starts to change the course of movement. Just like, look, it was coming down, now all of a sudden after this point it's going up. So this thing is this turning point or vertex. Now, if we have a simple graph, we could just simply read off vertex and just make the equation directly, which I have already made a video. In case, you can just check out my channel and you'll find it over there. But a lot of questions just don't give you the graph. They give you something called a regular equation. They say that you have an equation, let's just say 2x squared minus 2x minus 4, and now they say make this in completed square form. Now, in a lot of students gets confused in this, because the actual way of doing it and there's a shortcut way of doing it. The shortcut way is messed up, because as long as you're good with your squares and everything, you can do that one. But if you're not good, like me, then you're not doing it good. So there's a better way and an easier way to do this. But for that, we need to first see how the equation looks like. So ax minus h squared plus k. This is how a typical equation looks like for the completed square form. Now if I start expanding this, I'll see that this becomes x squared minus 2xh plus h squared plus k. Now if I further expand, I get ax squared minus 2axh plus ah squared plus k. Now, if you look closely, this is an equation, and the regular equation looks something like this: ax squared plus bx plus c. Now, if you closely look, you still have your three components, like your x squared, and like your x, and in the end, you also have your constant, like here, constant, and this is your constant. So this means you can compare these two and find your answer. So let's use this example, how to compare these two things. So let's just find the equation 2x squared minus 2x minus 4. Now in this is my a, this is my b, and this is my c. Pretty simple. Now a still remains the same. So the coefficient of x squared is a in both the terms. A equals a. So in other words, a is just simply 2. One part is done. Now, in order to find your h and k, you're going to use the other one, the coefficient of x, the yellow one. So the coefficient of this yellow part is minus 2ah. And this thing is exactly the same as the coefficient of x here, which is your b. And your b in this case is minus 2. Now if you go further, you see minus 2 is multiplying with a. Do we know what a is? Yes, we definitely know what a is. So we multiply it with 2, and h minus 2 stays the same. This becomes minus 4, h equals minus 2. You simplify it further, you're going to get just 1 over half, because the minus signs cancel here and here. Okay, so now you found your h, you found your a. Last thing you need to find is your k. So you compare your constants together, because they're the leftover terms, right? So you say ah squared plus k is the same as c, which is minus 4 in our case, in this case. So what was a again? A was 2. h squared was half. and plus k equals minus 4. Now we further simplify, we see it becomes 2, 1 over 4 plus k equals 4, sorry, minus 4. This cancels, this becomes 2, is going to be half plus k equals minus 4. Take it on the other side, you're going to get k equals minus 4 minus half. You take an LCM, multiply it with 2. And then you have minus 8 minus 1 over 2, which is minus 9 over 2. Now you have your h, you have your k, and you have your a. So the final step, don't forget this final step, because this is the last one, because you need to show it in the form like this. So you just combine all of this. You say the completed square form is a, which is in our case is 2 x minus h, minus is minus half, square, let me just do this, plus k, plus minus makes it minus 9 over 2. Now this is your final answer, this thing here. Such a bad color. So yeah, this is your final answer, the purple highlighted part. And in this, you know what's your turning point. Your turning point is just simply half comma minus 9 over 2. Now notice how the turning point is not with a negative sign, because you can also see it, it's just h is just half, and in this equation it turns negative because of the negative from the formula, but it's actually 1 over 2. So this is your vertex slash turning point. And yeah, if we keep these things simple, these questions are really simple. You just need to know how to expand it. Like, I'm not saying to memorize this part, just know how to expand it. It's a simple algebraic expression, and once you learn to do that, you can solve any question. Now for your reference, I would recommend you solving this problem, which is minus x squared plus 4x minus 3. Make it into completed square form. Now again, the idea is still the same as top, just give it a shot and see if you guys could do it, and put your answer in the comment section. That was it for today. If you need more help with these high school first level, high school 11 international, the first year university courses, you can put it your subjects or the things in the comment section, and I'll try to make a video on that one. And until then, see you, have a nice one.